I'm just going to show you a display that we've made, so to show some of the capabilities that we have here at Electric Drive Engineering. Now, we've built this display in conjunction with a customer of ours who has developed, using our motors, an electric a Mulcher attachment for their Escalator, and an electric generator which charges the batteries from the diesel motor to run the excavator. Okay, now this is the user interface for the system. Now, and I just want to go through how we would go about developing this. So initially we have a meeting with the customer to kind of get their requirements. We've done a few of these so we kind of know the capabilities of the display. So we describe to the customer what are some of the things they could be capable of. Here we're just looking for features. So we can see that we've got a battery in the middle. We want current, showing the generator current going into the battery, current going out into the motor system. We want to be able to control our water pump, key switch to turn it on, forward, reverse, stuff like this. We then program that up as a demonstration, make sure we get all the functionality right. Now, this is like completely functional, but just doesn't look quite professional. So although we get all the functionality working at this point, we then take it, think about how we want to look at it graphically, and we find some symbols that we can use. We're aiming here to use, minimize the amount of words. We want the function of each button to be just intuitive and not necessarily need to be explained, or only explained once and then it kind of just makes sense. We then take it to a couple of graphic designers. They come up with their concepts. We take one that we prefer and then work with that artist with a couple of back and forths to improve some of the icons. You can see we eventually landed on a different icon. This setup was different. And then this is the final product. So in the top left, we have the power on button. So to turn the system on, you press the power on, and then you turn the water pump on, and these two would control our relays. Now, we actually have the system on already, and we're using our dyno to simulate the two motors. So this motor on the right is acting as the mulcher, and then the motor on the left is acting as a generator. So it's actually braking this motor. Right, so to start the system, you would press the motor on button and then put it into forward, and we can see that the motor is starting to spin at 1,000. And the generator is braking at 1 amp. Now we can adjust the speed of the mulcher with these two buttons. We can go into a kind of faster mode and then a slower mode. Now, one of the things that's important with the mulcher is that you may want to slightly finely adjust it, and then you can do that with this dial. So you can add sort of 10, 20 RPM to that speed. If you wanted to make a larger change, you can do that in the settings. Now, it was important to the customer that only those authorized could change it. So these are password protected. So if you get the password wrong, the change doesn't take effect. But if you get the password correct, it does take effect. Now, the other things on the page here, these are some of the variables that come from the motor controller. And we just have them here, and it's useful for debugging. And then these are the fault pages. You can see there's no faults right now. So we can start the system in reverse. Now I'll just simulate a fault by removing the encoder cable for one of the motors. And we can see that we have a fault light here in the top right indicating that there is a fault with the mulcher system. So we can go into the settings page, down to the mulcher, and we can identify that fault as an encoder fault. What's the potential cause? The input wire is off, and and then our recommended action, we can check the wiring. So this would allow the user to debug any easy faults. Okay, so that's it. And if you perhaps have a similar project, we can assist.